Yeah, that's perfect.
Awesome. Okay. Says null hypothesis mu greater than or equal to 80. Alternative hypothesis mu less than 80. So this one's a little bit different where they already give you that information.
Okay.
They tell you that it's a sample of 100, that's n. Sample mean x bar of 77.5. Population standard deviation, that's sigma. Sigma is 15. Compute the value of the test statistics, that's z. Z is x bar minus mu over sigma divided by the square root of n. X bar is 77.5 minus mu, which is 80. So the mu is always like, these are your mu values. Whatever's up here is your mu in the null and alternative hypothesis. Notice it's the same value each time. Sigma is 15 divided by the square root of 100. You want to calculate that for us, please? I'll do the same. Make sure we got the right number.
Mhm. 1.66.
So I got negative. Hopefully you got
Yeah.
to negative 1 point, and then you got to round to 2 decimal places 1.67. Does that look good to you?
Yeah, I got the negative too.
Okay. Now that's kind of consistent with the fact that it's a less than and the alternative hypothesis. Less than typically means that it's going to be a negative test statistic. All right, so now we can move on to part B, which is to determine the p-value. So we're going to use that z-value we just found. So to find the p-value, we're looking for the area in the curve. Okay, your z-value was minus 1.67. Your alternative hypothesis was a less than. That means we want the left tail, left of that line there. You want to find all this area to the left of that.
Okay.
So you're going to use normal CDF again. Your lower is minus 10 to the 99. Your upper is minus 1.67. Mean of 0, standard deviation of 1.
So just typing that in real quick. Okay, 0.05.
So we're going to 4 decimal places this time. 0.04745. Okay, see how that's out to a 5th decimal place? Does that 5 cause the 4 to round up or down?
Up.
So it's 0.0475, like that.
Okay.
It's just like we talked about before, if the p-value is less than alpha, and this is the way you want to remember it, you reject. Your p-value is 0.0475. Is that less than 0.063?
Mhm.
Is that true? Yes or no?
Yes.
It is. So that means you reject. In this case, you reject. Reject always goes with the word sufficient. So reject sufficient. Letter D.
All right.
All right. It's part C here. So this is that critical value stuff. It's like, what is this critical value stuff? So you go back, your alternative hypothesis was a less than.
Mhm.
Okay. And that tells you the critical value is going to be over here in the left tail. This is your critical Z value.
Okay.
They're telling you alpha in this case is the area under the curve. They're saying the area under the curve is 0.063. You've got to find this Z value. Okay. You use inverse norm to find the Z value. Your area is 0.063. Your mean is 0. Your sigma is 1. Okay, so go ahead and calculate that for us, please.
Negative 1.53.
Good. So that is negative 1.53. So because your alternative is less than,
Mhm.
I believe the negative 1.53 goes here and the word none goes here. Okay, because it's less than is why it goes in the top
Okay.
one. Please check that. If it's not, it'll be the flip of this.
Okay, let me submit that. Yep, that's right.
Great. So like I said before, it's the same conclusion. So you don't have to like reinvent the wheel on this one. You know what it is. It's reject sufficient. Okay. We can
Okay.
get into how you just use the critical value, but the p-value and the critical value have to give you the same results.
Okay.
They just have to. Okay. Yeah, questions on that before we move to 19?
I think that's all.
Great. All right, 19. The average US daily internet use at home is 2 hours and 20 minutes. Okay. A sample of 49 homes in a certain city showed an average usage of 1 hour and 35 minutes with a standard deviation of 90 minutes. We are interested in determining whether or not the average usage in the city is significantly different from the US average. Okay. All right. So good to maybe read it one more time again. The null and alternative hypotheses are always going to have a mu until otherwise stated. Okay. The claim here, this is the claim. We'll read it again in a moment. The claim is that it's different. Different means not equal to. Okay.
Okay.
So that's going to go down here in the A. So just to be clear, to enter that, it's this exclamation point followed by an equal sign. When you hit the space bar, or it should automatically convert that into that symbol there. Like it's not this. You definitely don't want that, but you have to type that and it should convert to that.
Oh, it doesn't. I don't see it converting. But yeah.
I agree. I believe it's under relations though. It is not. Huh.
Maybe
Wow.
I'll just try and enter the answer with it like that.
Oh yeah. Yeah, that might be the way it goes. Yeah. So the number we want is the one that we think is true. Okay, so it says the average US daily internet US home is 2 hours and 20 minutes. That's mu. Okay, that's the number. And so we know the 2 hours is 60 minutes plus 20. So that's 140. So we're certain that the population has 140 minutes of internet usage a day. Okay.
Yep.
The rest of this is a sample of, that's N, showed an average of 1 hour and 35 minutes. Okay, so that's your X bar. X bar is your sample mean. That has to be converted to just minutes. We'll do that in a moment. Standard deviation sigma of 90. Okay, so your test statistic is Z equals X bar minus mu. sigma divided by the square root of n. Your X bar is 1 times 60 for the 1 hour. Add the 35, that's 95 minutes.
Mhm.
Minus 140 over 90 divided by the square root of 49. So notice the similarities to all the other problems. You're calculating some sort of X bar. And then you are, or I'm sorry, you're calculating some sort of Z from the X bar, mu, sigma, and N here. Let me know what you come up with for that.
Negative 3.5.
Yes. All right, so that's the first part. The next part here, and were you able to get the null and alternative in there? I don't know if you had a chance to check that or not.
Yeah, I did.
Oh, good. Part C, okay. All right. Let's do, we'll just do them in order here. Make sure we get all this done. Okay, part C is this critical value stuff again, okay? So they're telling you the alpha level, your alternative hypothesis is a not equal to, that's two-tailed.
Okay.
So what that means is that the area 0.05 is divided among these two regions. You have to take your alpha and divide it by 2. 0.025. That's in this tail 0.025, and in this tail 0.025. This is where you got to go to inverse norm again.
Mhm.
Area is 0.025. Standard, I'm sorry, mu is 0, standard deviation is 1, and get that value that goes in there.
Negative 1.95.
So again, that's going to round up though. What does that?
2.0 or no?
2 decimal places. So you got to go out to that third
Oh,
one.
okay, 1.96.
Yes. And then the other one is positive 1.96. The reason you need both this time is because it's a two-tailed test.
Okay. Oh,
All right, so to
I
close
didn't
this
like
out,
those numbers.
I'm sorry.
I said I didn't like those numbers for some reason.
Interesting. 0.05. Oh, 0.025. Well, so what I'm going to do here is, and this is a good thing to do to kind of figure out why this is having a problem here, is I go to the practice another,
Okay.
and this is somewhat helpful here. You do unfortunately have to enter stuff,
Okay.
but what it allows you to do, and hopefully it will do that here, is it will show the answer. And try not to think of that this doesn't actually mean that it will work every time. There is some patterning here, but the numbers do change. So interestingly, why does it do that? So these are the right answers, I believe, but I'm wondering if did you guys start talking about t-tests in class? Do you know?
The last class we had was just our test.
Your test. Okay. Let me try this one. Degrees of freedom 48. And then we said 0.025, calculate. Okay, so this one is a t-test, which I wouldn't have known unless we had done this. So just go with those values for now, and we'll talk about, if we need to in the next problem, why it's a t-test.
The -2 point.
Yes, yes. Let me know when you get that down. I'll go back to the other screen here. We'll,
Okay, yeah, I got it.
okay. All right, so can we move on to 20 now? Oh, we have to actually answer the question. So to decide whether you are going to accept or reject your test statistic was -3.5. Okay, your critical values were -2.01 and 2.01. So this is called your reject region and your reject region. Your computed test statistic was -3.5. Did it fall in the reject region? Is it left of this one?
Yes.
Yes. So you would reject it. Okay. So the other possibilities that you take your test statistic and you compare it to the critical values. So in your problem, you're going to choose reject and then sufficient. But this one doesn't say that, does it? Of course, it switches that up. So let me snip it in here. All right, so we know that it is.
Says we can conclude or we cannot conclude that.
Can. The can conclude usually refers to the alternative hypothesis.
Oh, okay. Yep, that's right.
All right. So this is what we just saw is the real challenge of this part of the course, which is knowing whether it's a Z or a T distribution. And you can see where we did the last one. We used the wrong one, we get the wrong values. Okay. So what is it that makes the differentiator between a Z and a T? And it comes from whether you know the population standard deviation. This is a sample standard deviation, and that's why it's a T test. Okay, but that doesn't affect the null and alternative hypothesis at all. And that's maybe why this is so confusing, because it actually only affects your test statistic, kind of, and then the p-value mostly. All right, so this one's actually kind of a lot like the ones we've been doing. A sample of n equals 81 showed an average balance of $1,200, okay, with a standard deviation of 124, okay. Formulate the hypothesis that can be used to determine whether the mean of all account balances is significantly different from 1140. So these are both mu's. Significantly different is not equal to, so you're doing the one like this. And then the mu is always an equality, some sort of inequality. And so that word significantly different is what leads you to this symbol right there, the not equal to.
Right. That. Okay, that's good.
All right. The next thing it asks for is the test statistic. So the thing is that like it's not any different than what we've been doing, which is I think good and bad. It's like, why are they distinguishing between? So your T is X bar minus mu over S divided by the square root of N. So it's really similar. It's really, really similar. Your X bar is 1200. Your mu is 1140. S instead of sigma, that's 124 divided by the square root of 81. Now it's to 3 decimal places though. So typically T's are out to an extra decimal place in your course. So let me know what you come up with for that, please.
Negative 0.0179.
We're on. We got different numbers altogether. So let me redo mine. Make sure you get some parentheses. I didn't add them
Yeah,
that time.
I didn't do the parentheses.
Okay.
.35.
So one more decimal place. So is it
4.
4 or 5 on the end there?
It says 3 decimals, right? So
Yes.
it would be 1.4 or 4.4.
So that this means to the right of the decimal point.
Oh, okay. Oh, okay.
Good.
So it stays the same then. Sorry.
Okay. So again, like it's 3, 5, 4, 8. That's 4 decimal places. You
Yeah.
use the last one to decide whether this rounds up or down.
Okay.
So it becomes 4.355. Is that okay?
Yep, that one works.
All right. So the next thing here is part C, which is the p-value. For the t distribution, it's a bit more complicated. You may have to use a table, maybe not. I guess because this is 4 decimal places, you're probably using software. So here's what's happening. Your t value is 4.355 here, but because your alternative hypothesis is not equal to, you need to get this area and then double it. Okay, and it's because it's a not equal to. Whenever it's a less than or greater than, you just get the area. But this one you gotta double it. The next thing is that you have to find this degrees of freedom value. The degrees of freedom value is the number of samples minus 1. So in your problem, the samples are 81 minus 1 is 80.
Okay.
All right, so if you go to second distribution, you're now going to use TPDF. Do you see that there?
Yep.
All right, now the problem here is I don't know the syntax again, so I need to quickly look that up. It's probably going to be lower, upper, mean, standard deviation, and then degrees of freedom, but I'm not sure. So let me just quickly check here. X comma V. All right, let me try this here. So we're going to go 4.355 comma 80. Let's see if that actually works. Okay, didn't seem to like that. I'm sorry, is there a TCDF? I'm sorry, I was looking at the wrong thing. Second distribution. Sorry, you want TCDF. I don't know why I said PDF. You want TCDF.
Okay, yeah.
And let me try this again. All right, so didn't like one of the arguments. Yeah, because I don't have enough. Why can't you just tell me what you want? Okay, so it is lower, upper, and all right, so okay, so this did work. All right, so here's how I use TCDF. It is lower, upper, and then the degrees of freedom. So your lower is 4.355. Your upper is 10 to the 99, and your degrees of freedom is 80. So go ahead and try that.
1.95.
And there's a bit more there. It's times 10 to the minus what?
Oh,
I think it's just minus 5. Is that what you said? Yeah. So what that means, and that's why this is a little bit more difficult, is it means move your decimal place left 5 times. So 1, 2, 3, 4, 5. Put zeros in there. 1, 2, 3, 4. So this number is really 0.000195. They want the answer to 4 decimal places.
okay.
So it's 0, because you can see that the 5th digit doesn't round this one up.
Yeah.
1 rounds it down. So like you could guess 0 in a lot of cases, but I mean, you got to know how to do the calculation there as
Yeah.
well. Okay, so that is the p-value. That's a reject situation because the p-value is less than alpha. Like I don't even know what alpha is. I guess it says 0.05. So part D here, p-value, is that less than alpha? Is 0 less than 0.05? Yes. That means to reject. Reject, there is sufficient. Reject tends to go with sufficient.
Perfect.
All right, so we'll go back to number 2. Does that work for you?
Yeah, that's fine.
All right, number 2. Here we go. These are going to be much easier. So the only the mu, the H0, the only correct mu zeros are the following. It can either be mu equals, mu greater than or equal to, mu less than or equal to. These are the only correct H0s. Okay.
Okay.
So you can see that A is wrong, B is wrong, and it's down to C or D. Okay.
Okay.
Now we go back to reading it, okay? Because that's kind of that first part. A machine is designed to fill toothpaste tubes on an average with 5.6 ounces of toothpaste. So that's the number. 5.6 is what they're giving you. Manufacturer does not want any underfilling or overfilling. So basically, they're saying like we want it to be, we don't care whether it's, we want it to be right at it. Okay. And so that's what this one says. This one says right at it. If it wanted underfilling or overfilling, that's when you'd have a greater than or equal to or less than or equal to.
Okay.
So you got to be able to convert those words, under, over, less than, greater than, all that stuff.
Yeah, that one's right.
Okay. So again, kind of same thing here. Again, the H0 has to be either a mu equal, a mu greater than or equal to, or a mu less than or equal to. So that's kind of something you'll see on your test. That means that's out and that's out. Okay.
Because
so in the
it
first
doesn't
one,
have a line under it.
that's right. In the first one, it's less than. We want less than or equal to. So that's why that one's out. The third one's a greater than there. And it has to be either greater than or equal to or less than or equal to. Okay, so your null hypothesis has to have an equality in it.
Okay.
All right, it says the manager of a laptop computer dealership is considering new bonus plan in order to increase sales. Currently, the mean sales rate per salesperson is 8 laptops per week. Which of the following is the correct set of hypothesis for testing the effect of the bonus plan? So this is where you've got to be able to interpret what it's saying. You have to know, like, kind of like use your, your experience in the real world. If they want to increase sales, is the mean number of laptops sold going to increase or decrease?
I'm sorry, what was that again?
Well, so I'm asking you if the bonus is based on increasing sales,
Uh-huh.
will they sell more or less than 8 laptops in that scenario?
Probably more than 8.
More than 8. So the claim, and this is where you're going to your alternative, your claim, this means increase. This means decrease. So you're looking for this one in the alternative hypothesis. So out of B and C, which one has this one in it for increase?
Mm-hmm. Well, they both have an increase and a decrease.
In the alternative, though, you're looking at the second one.
Yeah, the HA, you're right.
Yeah. So which out of B and D, which has an HA showing an increase with a greater
Oh,
than?
okay. Sorry. The D, the last
Yes.
one.
Yes. Yes. Good.
My bad, I just got confused for a second.
It's okay. We're practicing for something in the future test or quiz. All right. I'm just looking here to see if there's any better order to do any of this in, but it doesn't appear so. So we'll just go in order. So number 4, snip that in. If a hypothesis test leads to the rejection of the null hypothesis, a blank have been committed. So there's really only 2 types of errors in this course. You'll see what's called a type 1 error. Okay. And this occurs when you reject H0, but it's actually true.
Okay.
Okay. So if you reject the null hypothesis, the only possibility is a type 1 error.
Okay.
So that means it's either A or B. The language here leads me to believe that they're trying to get you to see that it may have happened. There's no guarantee that it did happen. Okay.
But
So
the
I guess
only way for it to reject is if it actually.
a type 1 error only occurs when you reject H0. That's
Yeah.
the only possibility. Because and that's where I was going with this, is a type 2 error occurs when you fail to reject.
Mm-hmm.
And we can get to that if we need to. So it's either A or B here. I'm suggesting that it's a may because we actually don't have any guarantee of a type 1 error in any scenario, as far as I know. It's just a probability of. So if you're asking me, I would probably tend to go with A.
Yeah, that one's correct.
All right. We'll go to 6 and come back to 5 because 6 refers to this type 2 error. So a type 2 error occurs when you fail to reject H0, but it's actually false.
Mm.
And you'll see these in class, and hopefully they'll give you some background on that. So when the null hypothesis is not rejected, that's fail to reject. It's a type 2 error. It's a possible type 2 error. Okay, that's the only possibility.
Okay.
It may have occurred. We don't know. So you will get some version of that on your test quiz because they really do emphasize, what is a type 1, what is a type 2 error. Practically, it's referring to things like false positives and false negatives
Okay.
that they will likely cover in the class. Okay, if the null hypothesis is rejected at the 10% level, okay, so here's what that means. That means alpha is 0.1. So you reject when the p-value is less than the alpha level. So let's just pick a p-value. Let's pick a p-value of 0.08. Is 0.08 less than 0.1?
No. Oh yeah, sorry.
Yes. And so if you need to, you can always add digits to make that clear. So this is true. Okay. All right. That's good. That's kind of scenario one. But then it's saying, well, what happens at the 1% level? So what if alpha is now 0.01? Do you reject? Is 0.08 less than 0.01?
Yeah.
8 compared to 1.
Oh no.
So
Sorry.
this is false.
I was thinking about the first one.
It's okay. So notice like we used a number. This is a test taking strategy. Use a number. Okay, it works in the first one, but it doesn't work in the second one. Okay.
Mhm.
But here's another possibility. Okay. I'm gonna use some different numbers here. Let's say it's now 0.008. Is that less than 0.1?
I'm guessing
So
yeah.
you just go digit by digit. Is 0 less than 1?
Yes.
It is. So that's true. Now let's do the same thing for this one down here. 0.008, is that less than 0.010?
No.
So you got to go digit by digit. 0, the first 0 is the same.
Uh-huh.
Then the next 0, you got 0 and 1. Is 0 less than
Yeah.
1?
Yes.
So this is true. This is now true.
Okay.
So in one scenario, it was true false, meaning it worked in one but not the other. In the other scenario, it was true true, meaning it worked for both.
Mhm.
So here's our answer. We can't say that it will always be rejected because we just saw a scenario where it wasn't. It will always be rejected. Okay. When we said true false, that's the may be rejected or not rejected.
Maybe rejected.
Maybe because we saw a case where it was and then a case where it wasn't. So we don't know.
Mhm.
To your credit, you're trying to do this like ahead of time before you've seen it in class. Fortunately, like there's some things here that probably are not going to make any sense until you see it again in
Uh-huh.
lecture. But the general idea is if
Yeah.
the p-value is less than alpha, you reject.
Sometimes it helps me if I kind of have an idea about what we're getting
Yes,
into. I can pay attention better.
it's a great way. It's a great way to do it because you've heard it before and you're not just
I'm
hearing it for
not
the
trying to
first time.
figure it out in class.
Yeah, exactly. Okay. So we have said this. I mean, I've said this probably 20 times among the couple of lessons we've done here today. When is the null hypothesis rejected? If the p-value is less than alpha. Okay. And I guess it's a less than or equal to. That's why this one's correct. But that's what I've been saying over and over and over again. Like that's so important to get down so that you're not unsure of that.
Mhm.
Okay, let's look at number 8. Okay, so it says H0 mu less than or equal to 800. The claim here is that mu is going to be greater than 800. So in terms of our normal distribution, whenever you see a greater than means right-tailed.
Mhm.
So it's going to be over here to the right. So you're going to calculate some z value and you're going to have a critical value right here. So this on the right is called the rejection region. And on the left here is the fail to reject. Okay. So in this scenario, you reject if your Z value is greater than your Z critical value. And graphically, here's what that means, or here's where it is graphically. It's something right there to the right. You fail to reject if Z is less than Z critical in this right-tailed test only. And graphically, what that means is a point somewhere over here to the left of your critical value. So they don't use Z critical, they use Z alpha in this problem. So you think of Z critical as Z alpha.
Mhm.
So this is what you're looking for. You reject if Z is greater than Z alpha. So it looks like letter C.
Alrighty.
All right, number 9. All right, if the null hypothesis is not rejected at the 10% level of significance, so this is alpha, we reject if the p-value is less than alpha, so our alpha is 0.1. So since we're not rejecting, we need a p-value that's bigger. So think of like something like 0.2. 0.2 is bigger than 0.1. That's why you reject. Not rejected, sorry. Okay. So you fail to reject or do not reject if it's greater than. But now let's say the alpha is 0.01. Is 0.2 still bigger than 0.01?
Yeah.
It is. So it's do not reject or fail to reject. So can you think of a number that's bigger than 0.1 that's but smaller than 0.01? That's what this question is really saying. A number bigger than 0.1 but less than 0.01.
Would it be another 0? Or wait.
So if you like, here's what I think I heard you say, and because this is the right line, I think it's like, what about like 0.002? Well, that's not bigger than 0.1. So we're looking for a number, and we don't know if it exists, but we're looking for a number if the p-value it's bigger than this, but less than the 0.01. And there is no such number.
Yeah.
There is no such number. So this will also not be rejected. There is no uncertainty there. I don't know if you had any of these on your last test, but it was kind of like if n increases, what happens to the confidence interval? If C increases or alpha increases, that's the style of question that these are. Okay, number 10 here, kind of the same thing here. It's if the null hypothesis is rejected at the 0.05 level of significance, it will blank be rejected at the 0.1 level of significance. So let's go case by case here. So here's alpha. Alpha is 0.05. Here's your p-value. If we're rejecting, we need a p-value to be less than 0.05. So maybe 0.025. Is that less than 0.05?
No.
Gotta go digit
yeah.
by digit, right? So
Yeah.
we reject if the p-value is less than alpha. Reject if the p-value is less than alpha. This is good. So now the next scenario, here's 0.1. Is 0.025 less than 0.1?
Yes.
It is. So you also reject. Okay. So what we're looking for is like, is there a number that's less than 0.5 that's somehow greater than 0.1? Like, does that exist? A number less than 0.05, but then greater than 0.1. And I think what happens here is because these are decimals, it gets really confusing. But if you make a graph number line. We're looking for a number that's less than 0.05. That's somehow greater than 0.1. Is that possible?
No.
No, it's not possible. Okay. So if you reject at the 0.05 level, it will always be rejected at the 0.1 level of significance.
Mhm. Okay. I don't know if we did number 6. But
Let's take a look.
oh, right there.
Yeah.
I just didn't have it down.
And just double check. We got 3 minutes left. Just double check that all of you got them all answered, or if you haven't run out of
Yeah.
solutions, we can quickly do that.
Everything looks good.
All right. Is there anything else I can quickly answer for you? Time we've got left.
I think that's really all.
Excellent.
Yeah.
All right.
Thank
Let me
you
go ahead
very
and
much.
yeah, let me go ahead and stop the recording here.